and welcome to the second of our debates here at IPC APEX EXPO. Line optimization and interconnection using inspection software suites. As always, we have a very eminent panel to discuss these topics. To my extreme left, we have Brian D'Amico, President of Koh Americas. Next to him, we have Ivan Aduna from Koh Young. And to my left here, we have Subodh Kulkarni from Cyber Optics. So welcome, gentlemen. Nice to see you, and thank you for joining us today.
Good to see you.
Pleasure as always. Nice to see
There
you
you
as
go. There's a growing variety of software suites out there that are integrating along the CFX backbone. And we want to talk a little bit about these and how to optimize the process, traceability, and yield. So my first question I'll give to Brian, which is what features should manufacturers expect from these software suites?
Okay, well, ultimately, of course, CFX is a standard for a protocol for communication throughout the line. Mm-hmm. There's actually several standard communication, types of protocols to communicate throughout the line. But the whole goal is to take all of the machines and kind of make them communicate together, but to collect data from that line. The goal with any of these, and we all have these, right? The goal with any of these AI type systems is to collect deep learning data, to collect as much data as possible, and then to take that data and use that in order to create process parameters that make the line both as efficient as possible, maximizing quality, maximizing profitability, and making life better for the customer.
Right.
One of the key things that there's an issue with is finding the right people to run a product line, right? So if you have a really good process engineer and you lose that process engineer, it's like losing your best chef. When you lose your best chef, your restaurant may not do well. The whole goal with these products that we sell is to really make it so that we can have anyone run that line, or virtually anyone run that line, as good as the best process engineer that you could find, because there's a lot of turnover in this industry, you know that, right? So what we need to be able to do is collect the data, take that data, process it, and make parameters, like for the screen printer, for the pick and place machine, for the oven, make those parameters or suggest those parameters that make the line as efficient as possible. That's what we all kind of do.
Right. I mean, with modern GUI software, though, I mean, presumably you try and make it as simple as possible, but you can lock it down at different levels if they need to go deeper to be able to really get into programming it. You got any comments on that, Ivan?
Yeah, absolutely. So for example, right, as Brian was mentioning, the purpose is collecting as much data as possible, and that with the purpose of monitoring, control, optimization. But with the deep learning or going deep into the harvesting this information, which for inspection systems, for inspection companies, going all the way down to the measurement information, and that combined with other equipment down the line, now you can think about what else, what can you use this data for, what purposes, such as closed loop modules, AI engines that can be processed and get optimization tools that will literally save tons and tons of times of troubleshooting, debugging, process engineers that won't have to be in there to resolve all the issues in the background.
Right. Suppose, I mean, Cisco's mantra is what data should you collect? You should collect everything because you don't know what you're going to need in 5 years' time. So, I mean, would you agree with that? I mean, because that you end up with silos full of huge amounts of data that you...
Yeah, I mean, by definition, data is always good, but there is a difference between just numbers versus information. And that's the key here.
May I have your attention,
You cannot...
Keep going.
You cannot just keep collecting data and you'll be full of petabytes in no time. So the way we at least look at it is you have to structure the data at various levels. You have like a sensor level data, then you have like a system level data, then you have line level data, then you have a factory level data. And then sometimes corporations are global enough that they want a global level data.
Right.
And analysis changes depending on what level data you are looking at. And with the advent of advanced GPUs, that's really where the information has to be processed correctly.
Right.
So ultimately, exactly as my other two peers said, ultimately you want to make life easy for the customer, improve their yield, improve their productivity. That goes without saying. But how do you process the data? How do you integrate it? How do you make it seamless? That's where the key comes in.
Yeah. Well, it's an ongoing challenge, I'm sure, for all of you. Brian, what will inspection software? I mean, when you go to do an installation, do you try to work with other third-party machines? I mean, if a customer's already got an inspection machine, which is not a Mertec machine, for example, are you able to integrate with that and extract some data to use in your system, or is it proprietary?
Well, and the whole thing is, of course, because there's competitive systems out there. So there'll be competitive SPI, competitive AOI. But ultimately, I think that we're all kind of along the same path here where we all want to help the customer with Industry 4.0. There are definite benefits to Industry 4.0 in that they're going to be able to, once again, make their process better, right? Make boards as with zero defects on them, or as close to zero defects as possible, right? But in order to do that, we really need to be able to communicate with all the machines. And for that, we need to be able to communicate with the other vendors. So to some extent, there are certain parameters that, of course, aren't going to be available to us, right? We'll try to get as much data as possible. One of the things that we have chosen to do, though, is we use third-party vendors like Cogiscan, which is kind of like, neutral. It's kind of like Switzerland, right? So you got Switzerland. You can collect the data and you can bring it into the Cogiscan. That's one way of ensuring that we can get that data and help customers out. There's not too many projects that we have, directly with other inspection companies. But once again, there are those different middleware type companies that allow us to kind of make that process easier and more seamless across the line. We're always going to have challenges, right? There's going to be legacy products out there that we need middleware for. Anyways, that may not be CFX compatible. But there's ways around that. There's ways that we can, and I believe that we're going to have more of an alignment throughout the industry, just because customers are going to want that. They're going to dictate that. They're going to say, I want to buy your SPI machine, your AOI machine. Now get along in the play box, right? In the sandbox together. Yeah. And so we will make that happen.
Yeah. I mean, Ivan, I think Brian's entirely correct in saying that, it's never going to work. Nothing's going to work as well as it will with your own software. You'll get the optimum results working with all Mertec machines, or all Koh Young machines, or all Cyber Optics machines. But I mean, the pick and place industry went through this right back at the beginning. They tried to go proprietary and say, well, you have to use our system. And then they very quickly realized that it was cutting off a lot of the market, because they would go into a factory and they say, well, the EMS guy would say, well, I'm not going to scrap half my equipment just to be able to buy your system. So you really have to learn to play together in the same sandbox. Would you agree?
Yes, definitely. And that's, I think, what has changed recently with the connectivity, that in the past, everyone had their own solution, right? You must use that solution and only that solution, and there's no way to communicate to any other vendor, whether it's competition or just simply another supplier. You cannot do that. But again, that's, I think, has changed. For example, now we have companies such as Arch Systems that they're fully dedicated to harvest and collect information, not only for Koh Young machines, but we're talking about entire lines, pick and place, printers, competition, and now not only at a factory or land level, but at a global scale. Because we have these big companies that they not only have 1-2 machines, 1-2 lines, they have 1,000 machines all over the world with more than 50 factories.
Right.
So this level of collection of data and managing that data in a way that can be oriented to business analytics. Now we're not just talking about operation, but asset management, which is, I think, the next level of really introducing the capability of connecting machines, having all your assets, all your systems connected in an environment that is basically seamless for an entire ecosystem.
Yeah, I think that's absolutely right. I mean, Sabota, I've always said that I look at inspection machines as being the eyes and ears on the line. I mean, they literally are the communicating devices that manufacturers use. And as Ivan rightly says, it's not just going to be inspecting boards, it's going to be asset management and other applications.
I mean, by definition, inspection machines are generating the most amount of data because we are inspecting everything. And so a lot of value is there in that information. How you use that is up to the customer. But certainly, companies like Microsoft have done a very good job in this case of enabling the interfaces and all the standardizations that have happened. And most of us are forced to play in the same sandbox, as you mentioned. And it's good. I mean, in the And that is helping customers to enable all the machines to talk to each other, to process the information correctly. So this is the right direction we are all headed.
Yeah, I think it's healthy for everybody, quite frankly. But there you go.
Agreed.
So, Brian, obviously, if we are going to look at a more open interface, then how secure is it?
Yeah, security is always an issue, right? Security is as good as it is in your company, or if you're keeping data up on the cloud, there is going to be some security concerns. One thing you don't want is if you have a lot of defects happening, you don't want your competition to see that, right? There are things that need to be secure, but I don't think any of us are truly experts on when it comes to security. But there are definite challenges there, and as more and more data becomes available, like anything else, right? We're in a world where data is now available to almost everyone. Quite frankly, data is out there that you may not want to be out there.
Right.
So there has to be, depending upon especially what the customer is doing, if they're doing military work or what have you, there has to be certain levels of security that allow them to keep that data from getting out. Once again, it's mainly dependent on the customer. It's dependent on those different emerging technologies that are going to keep that data secure. But there are concerns. There's definite concerns out there for that.
Well, there are some standards coming through down the pipe from IPC. You've also got the recent, is it the CMCC standards for military that were released here in the United States. So, there are some systems coming in place to protect data.
There's some improvement in there, and that's what we're gonna see, I think, in the next upcoming years, because this is the question, the common question that every single company is asking us, at least for the past few years, because they're concerned, there are breaches, this is happening, they're having issues, big concerning issues with security, whether it's production information, product information that is being compromised. And of course, that really complicates the entire environment with their customers. And as us, as their suppliers, we need to commit to create a secure environment, and that can be done in a different manner. So of course, we were talking about CFX as this new standard, and they're promoting it as a very secure, because it is, right? CFX as a with the background of banking in the banking industry, if you ever done banking online, we know that is secure, right? We don't want that transfer to be lost in the middle of something, and that's the same principles apply to CFX in the inspection systems or production environment. So I think we're seeing some improvement. We're seeing some understanding of people in the industry of how we need to react, and we need to improve on the security, because in the past, we're seeing these USB sticks all around and all these connectivities, but that needs to be changed.
Yeah, yeah. No, I agree. So, Bod, I mean, can we expect AI to play a bigger role in all of this in the future?
It already is. I mean, AI continues to improve. If you look at just a few years ago, how AI was being deployed, it was really primitive. Whereas now with the
Well, it was really
computational
machine
power
learning,
available,
wasn't it, rather than AI?
it was really calling it an AI was an insult to AI.
Yeah.
But now with the kind of NVIDIA GPUs that are available and the deep learning algorithms that are coming along, AI is coming truly to the point where you can say it is approaching natural intelligence to some extent.
Right.
And certainly our machines, and I'm sure our competitors too, we are doing a lot more with AI than what we ever did before. Things that are literally not even visible to the human eye are being accessed through algorithms now. And when you look at the information being processed and coming out, and then you take a second look, and you are pleasantly surprised to see that you actually missed that defect and AI machine caught it. So it's very similar to what's going on in other fields like digital radiography and all.
Right.
AI has truly come to a fore right now.
Yeah. It's an interesting area. I mean, Brian, I mean, AI is starting to contribute a lot, but the bigger the manufacturer you are, the more data you're collecting. So presumably, the better you're going to be able to refine your process. So
Yes.
is it going to be a bigger bonus for the big tier one guys as it's going to be for a little tier three?
Well, it really depends. Of course, the more it is a matter of, and I kind of like to agree with these gentlemen as well. It is a matter of data. You want good quality data, right? But all right, when we talk about AI, I always say we're not really talking about like Skynet here, We're talking about basically collecting data and using deep learning algorithms and using those algorithms to determine patterns and stuff that it's really difficult for a human being to decipher. Really,
Yeah.
right? That's what AI is all about. The more data you have is the better. But AI is also suitable for smaller manufacturers as well, because once again, you're learning from the process that you're doing, right? If you're doing much larger scale production, yeah, you're going to learn more. It's going to help that process. But a smaller manufacturer will still benefit from that. Ultimately, the whole goal is to collect that data once again to develop process parameters that make your life easier. And that's what AI is doing. And AI has made a lot of advancements over the last few years. I still think there's more to go, absolutely more to go. But I think we're all kind of pleasantly surprised at what AI is capable of doing right now.
Right.
And we know it's going to be that way in the future. It's just going to just make sense.
Yeah. Okay. So, Ivan, where do you think the roadblocks are in the industry at the moment with regards to inspection?
There will be, of course, a couple of things. In regards to inspection, specifically the inspection capabilities, we're running into a point that is extremely difficult to reach certain areas. Of course, size, that will be a limitation, right? Of course, we are optical inspection systems, and they're going to be limited in size. That's one thing, right? We cannot go beyond certain point. Of course, we have, now we're talking about data, how we can manage that huge amount of data, how you can still get into the point that it is real time, that that information will not be displayed tomorrow, that you need today, right now, in order to understand or fix anything that is happening. And of course, we're talking then everything in regards to inspection. Now we're limited to the where we can see through the board, right? We cannot see through things, right? We're not X-ray, so we're optical, and that's always going to be a limitation, right? That will play a big role as an inspection company.
Right. It's interesting. I mean, of the three companies we've got on the panel today, none of you have got X-ray. So
No.
right, I know, I understand that, but it's true. If you're going to be able to see all the way through the inspection process, you want to see the AOI, the SBI, and possibly even the X-ray information. But anybody want to add why you don't have X-ray, or do you think it's just something that other people have got that expertise and it's better staying that way rather than trying to be all things to all men?
With Bertec, it's basically core competency. We had X-ray years ago. We did have it in the past. Unless you're making your own tubes, really, to make it profitable and be able to make advancements, you're not going to really. Unfortunately, X-ray does become somewhat of a commodity at some point, as many things do. But it just didn't quite work out with us. So we decided to stick with our core competency, and that is 3D inspection, right? That is 2D and 3D inspection. And that's where we put all our money into as far as investment goes. But of course, X-ray does definitely have, it does add a level of quality. I mean, none of us can see under a BGA. I mean, it's something where
with miniaturization and BGAs, as you say, I mean, they're a must-have now, in any inspection process. But there we go. Anything to add on the topic of roadblocks, technology roadblocks?
Certainly, a couple of things we are seeing, because we are playing more and more in the advanced packaging hybrid area, which is like the merge between SMT and semiconductor industry. Certainly, miniaturization of components is there for everyone. But importantly, because so many things are getting integrated at the silicon wafer level, we are seeing more and more shinier components, like in mini LED, micro LED, or even like direct glass kind of substrates.
Right.
So the challenges are reflective surfaces, smaller components, sometimes like things that are to be looked at and from a side angle camera, try to make the most from the optical information you can get. I mean, X-rays have a role to play, but X-rays obviously are slow by definition. So they want the speed of optics, but they want the ability to look as closely as possible. Yeah. So the challenges continue.
Right. But I think you've all pretty much come out with some solution one way or another to try and combat that. Is that correct? I mean, how do you deal with shiny devices?
Okay,
Right.
so we are seeing, of course, we're seeing more wafer level devices. That's just the way the industry is going. It actually presented itself in Asia first, took a while to get to us, but we're seeing that more and more. So when you've got these very shiny die surfaces, they're like mirrors, ultimately. So we've done a couple of different things. One is that we introduced blue LED, well, actually, blue DLP technology, and that does deal with reflectivity very well. And that's something that actually we had to do. We also have some high-end laser systems as well for dealing with that with our SIP inspection machine. We not only have the blue DLP moire, 25 meg camera, 6 micron lens, but we also have ultra high resolution lasers that deal with shiny surfaces. The problem is the more that you put onto a board, right, especially if you're talking about SIP, system and package, the more that you're congesting the board with, the more wafer level stuff you're talking about, smaller 03, 015s, there's very small devices. You really require the proper technology to inspect that. So you kind of need a Swiss Army knife for an inspection machine.
Right.
And it's just getting more and more complicated. So our job is, of course, to address those up-and-coming technologies that are actually migrating it here to production environment in the States and in Europe. But I think it's mainly being driven from Asia.
Okay. Anyone got anything to add on the shiny devices?
What we have actually done is we have taken advantage of the fact that we know it's a shiny device. So we take the a priori information and design some of the projectors and cameras to take advantage of that. So once you know it's a mirror-like device, you can align your projector and camera so the light comes directly at the camera. So our latest sensor that we have showcased in this show takes advantage of that. So it's not only a smaller
So
resolution.
does it automatically then? Because
Yeah, so we are taking advantage of the specular surface. So we are aligning, essentially you are designing the projector and the camera at a specular axis. So you
so the
take full
projector
advantage.
detects that it's too shiny and automatically adjusts to compensate.
Basically.
Right. Okay.
So that's one way to take advantage of the fact that it is a shiny surface. You may as
Right.
well collect all the information you can get from the shiny surface.
Okay. Okay. One of the other big problem areas in the industry is hidden pillow, or hard ones to detect, should I say? So, Ivan, what do you suggest is the best strategy for detecting hidden pillow defects?
Yeah, I mean, I think it's a very complicated, and again, this comes to optical inspection system that allowing to see those solder boards or know that whether the component is actually soldered to the board is extremely complicated. Of course, we rely on certain technologies, algorithms, especially basically relying on a previous conditions that now can take us through an AI engine that can detect or can estimate whether there's a helium pillow defect underneath or not, right? And that comes with complementary mainly issues, right? If you can detect whether there's a solder board or something that might be instructing the actual solder of the component, that might be give you an idea. But of course, we were talking about that. Without an X-ray, you cannot in a way guarantee that that will happen. But of course, give you a very accurate estimate, and that all relies on software, right? That's, I think, our main focus, that we're really exploding or technology and basically leverage on software to do all the variety of tools that we need, right? All of our tool set.
Right. Right. Okay.
One thing head-on pillow defects can use is a side-angle camera. So if you happen to have side-angle camera, there is a chance you may be able to catch that defect. If you just have a vertical camera, that does create a bigger problem. Then you are left with X-ray as the only option. So side-angle
So you
cameras
need
do
side
come
cameras to be able to
to see
detect.
something underneath the
Right.
joint.
Right. Okay. And just my final question really goes to the subject of board warpage. It used to be a much bigger problem than it is now, but is it still prevalent in the industry?
Yeah, board warpage is definitely prevalent in the industry, and each one of us probably have our own specs for maximum board warpage, and it is a challenge dealing with that. But we are able to calibrate the machines so that we can kind of eliminate that as much as possible now. But having said that, if you've got a very thin board and you've got a big belly to it, of course it's going to be a challenge, because you're talking depth of focus for some of these cameras that's kind of narrow. So when the board warps beyond that, you really, you're dealing with a problem focusing on the device, either up or down. There's a couple of different ways of dealing with that, from clamping, board clamping, which helps to eliminate some of the warpage, but beyond the specifications of our systems, like the maximum amount of warpage that we can handle, definitely would be an issue.
Right. Right. I mean, has the 5G boards that are coming in, they're bigger heavier boards. Are they an issue with Warpage? Does that present itself?
Certainly, warpage continues to be an issue, but with between clamping, vacuuming, most of us handle the boards pretty well. In our sensors, at least, we calibrate it so the sensor can, and we have a very good height range of 24 millimeter, so we can go across the board, keep calibrating it to the distances, so we can take care of warpage.
Take care of it.
But of course, it comes at an expense of computational speed. You do sacrifice some speed if you continue to calibrate it. So the best option is to keep the board as rigid as possible.
Right.
But if you can't, we can handle it.
Okay. Well, good. You got anything to add to that?
I
Ivan?
think I completely agree. I mean, in reality, we know that it's still there, but all these functionalities that we have, and we have special functions for all of our machines for Warpage, right? But I think the main thing is focusing on cycle time. But it's basically saying the question, right? Asking our customers the question: are you willing to sacrifice quality over time, right?
Right.
So over efficiency, which basically most of the time they say no, right? They don't want to have escapes, and that comes with the fact of managing the warpage in a way that sensors, as mentioned, can be adjusted in a way that it can compensate with the warpage, which yes, big boards represent, but also we've seen a lot with small boards, semiconductors, right? They have very thin boards, right?
Right.
And in that way, we need to also manage and compensate that warpage of the board.
Yeah. Great. Okay, well, gentlemen, I think we've had a great debate today on a number of topics involving inspection. So I want to thank you all for coming in and joining us. Brian D'Amico from Murtec, Ivan Aduna from Koh Young, and of course Subodh Kulkarni from Cyber Optics. So thank you, gentlemen, and thank you to our audience for watching live today. Coming up next is going to be the Keith Bryant Show, so things will get a bit lighter, I think. So we look forward to that. But for now, thank you for watching.